we now turn from production to discuss costs. And costs, similar to production, there's a couple of different ways that we can slice and dice and think about these different concepts of costs, right? But we're going to primarily be focused on the costs that are associated with producing goods and services. We want to first start and talk about the difference between explicit and implicit costs, and this is a big difference between accounting and economics, right? And so so often, many times, people have done an accounting class before, they take their micro class, or they'll take them at the same time. And so there are definitely some cost concepts that overlap, but we definitely view the world differently, right? So my example, my thought experiment for that is, again, I mentioned this, I want to quit my job, I want to open up a hot dog cart on ONU's campus, quit teaching, just go ahead and sell hot dogs all day long. I think it'd be so successful, right? But you could think about, right, what's the cost? And again, what is the economic cost of me opening up a hot dog stand? Well, right, if you ask an accountant, they're going to focus on the factors of production that you have to spend money on, right? The land, the labor, the capital. Think about the little cart. Think about the ingredients and the machinery that I might use. And I'm using my own labor, right? And so there's those costs that are what we call explicit costs, right? Explicit costs are those where we can actually see the money changing hands, right? I've got to write a check for it. It comes out of a specific account. And that's primarily what accountants are focused on, right? Is those actual expenses that are paid for those factors of production. But if you ask an economist, what's the cost of me quitting my job and opening up a hot dog cart? I'm quitting my job, right? My next best alternative to opening up a hot dog stand was keeping my job. And so whatever my foregone salary was, that's also part of what I have to give up in this decision to open up a hot dog stand. Economic costs are those things that I give up in a decision. So my salary, I'm giving up my salary. But do I actually have to write a check for my salary? No. It's just money that otherwise would have been there, but now is not. We refer to those as implicit costs, right? Implicit costs are those where we can't point to where the money is in an account to see what the cost is. Rather, instead, it's the cost that we incur where money doesn't have to change hands, but it's still something that we otherwise would have had to give up, right? So again, accounting, economics, a big difference between those two disciplines is the way that they count up costs, right? It's not that one is wrong and one is right, but historically, the purpose of accounting is to focus on measurement of financial information, right? And so the focus or the perspective that's adopted is usually on your firm or your client, but it's very much on an individual basis. And so, not surprisingly, they think about more of the factors of production, whereas economics, and I'm doing wide here, right? I'm going wide with this interpretation. Economics has been more interested in what's going on in the aggregate outcomes for the economic system. And so it's not just counting up the costs for your clients, but other costs that might be impacted somewhere else in the system. Because of that difference in their historical perspectives, they're designed to do different things, and so they focus on different kinds of costs. Again, it's not that one is right and one is wrong, though I love telling Matt Phillips that he's wrong all the time. Instead, right, it's just that difference in perspective. But in this class, when we're doing the economics, we got to make sure we're counting both explicit and implicit costs. We can also think about, so that was the story of me, but we can also think about a business trying to expand operations or something like that, right? So when a business is going to expand operations, they may have $1 million in the bank that they can use on opening up a new location or something like that, right? So yeah, the explicit cost is the money they have to give up. Implicitly, though, what else could they have done with that $1 million? Are there other activities that they could have undertaken that could have earned some kind of rate of return, right? Maybe they could just invest it in a very safe kind of investment, bonds or something like that earn some kind of interest. And so that foregone interest might also be an implicit cost. Again, it's not money that they see in an account, but it's money that otherwise would have been there if they decided not to expand their operations, right? So again, in everything, we just got to, from an economic perspective, we need to take into account both the explicit and the implicit costs of operations. Another way that we can slice and dice our costs is we can either divide all costs into either being fixed or variable. So variable costs are those costs that do change when output changes. Fixed costs are those that do not change when output changes. So the real question then is when businesses or when a firm decides to produce more output, when they increase their quantity, what costs stay the same and what costs go up? If the costs are staying the same, those are the fixed costs, right? But if they want to expand their output, the things they have to spend more money on, those are what we consider variable costs. So again, you can think about if Subway decided they wanted to increase the amount of subs that they produce, what are they going to have to spend money on? Those kinds of things that they have to spend money on when they increase their output, those are going to be examples of variable costs. Another useful way to think about fixed costs are those costs that, what if they decided to close down for the day, right? So if Subway put up the close sign and they didn't produce any subs for the day, are they still going to incur some costs as a business? Sure they are, right? And so you could think about like their rent. Their rent is still going to be the same amount, even if they decide to put up that closed sign. Their insurance is still going to be the same amount, even if they put up that closed sign, right? All of those things that if they decided to produce nothing at all, that they'd still have to pay for, those are examples of fixed costs. And so an interesting thought experiment is think about electricity, right? If Subway decided to put up their closed sign, does that mean that they wouldn't have any electricity costs for the day? Right? The answer is no, right? They would have some electricity costs for the day. But also think about if they decided to produce more subs, if they increase the amount of subs they produce, is that going to impact their costs for electricity? Sure it would. They'd have to run things more often and use up more electricity and have higher costs, right? So there are oftentimes costs are going to have both a fixed and a variable component to it. There's a certain amount of it that's going to be used regardless of how much output is produced, and then there's also a portion that's going to be influenced by the amount of electricity that's produced, right? So oftentimes that's the case with many of these things. They don't clearly fit into one category or the other, but they're often a blend of both some fixed and some variable costs. If all costs fall into either the fixed or the variable category, though, we have this nice little identity, and I like mathematically how we've got this thing. And so let's go ahead and make this guy a little bit bigger to point out what's going on with it, right? So I've got all costs can either be fixed or variable, but just like if I've got f of x, remember that this is the value of the function for a given value of x with that notation. What we've got here is that VC for variable cost depend on, they're a function of the amount of output, the quantity that's produced, whereas FC fixed costs, they don't have this, right? Fixed costs are just a number. It is just a number. It does not depend on the amount of output that's produced. It is not a function of Q, whereas total costs are the fixed plus the variable, and so because they depend on the variable, they also will be a function of Q. I like this little identity, and I like having this notation about functions to remind myself about what is a fixed cost and what is a variable cost. An easier way to write this is just total cost is fixed cost plus variable cost. Do you recall what the three measures of productivity were, right? So we're about to look at three measures of cost, but as a review, what are the three main productivity measures? And I paused real quick and filled in a little bit of this information, and so you may want to pause this and fill in these parts of the notes, right? And then I'll just talk through them. We've got three main types of cost measures. We've got the total cost, and again, we just defined that total costs are equal to your fixed costs plus your variable costs. And then we've got averages, but we don't have just one average cost. We've got three different average costs. We have a TC for average total cost, a FC for average fixed cost, and a VC for average variable cost. And so we can define these mathematically. The average total cost is the easiest one, right? We're just taking my total cost and dividing it by Q, right? So again, to talk about the difference between the total cost and the average total cost, I might tell you that last year GM spent $360 million in their operations, right? Yeah, that's a useful piece of information. And it's a pretty easy one to get for a lot of public companies, right? The total cost of their operations are something that you wouldn't have to dig that far into their financial statements to try to identify. Their average total cost, though, what they're doing, right, is we would take the total cost and divide by, not the amount of labor, but here we're dividing by the amount of production. So if we're talking about GM, that would be the number of cars, right? And so we could think about what's a reasonable value for the ATC for GM, right? Think about, on average, how much does it cost for GM to produce a car, and give me what you think your best guess is. And so maybe one of the things that you found useful in trying to think about what a reasonable value of their per cost of producing a car is what do they sell those cars for, right? If GM is profitable, then the average price of a GM car has got to be covering these costs, right? Average total cost is simply saying we take all the costs and we divide by the amount of units that are produced. And so you could think about this is a per unit produced, per cars. Or if we're talking about Subway, this is the cost per sub. Or if we're thinking about a university, this could be per cost of educating a student, right? You could think about what that value might represent. The average fixed cost and the average variable cost, as their name implies, they're pretty straightforward, right? So the average fixed cost is simply taking the value of the fixed costs and dividing them over the quantity. And the average variable costs are just simply taking the variable costs and dividing those over the amount of units that are produced. We take our total costs and we break them out to either being fixed or variable. And then if we just divided those fixed or variable costs by the number of units that are produced, we get the per unit amount of fixed costs or the per unit amount of variable costs. And so a nice little algebraic identity, right, is we can do TC equals FC plus VC. And if I just divide through by Q, what am I left with? On my left-hand side, I've got ATC, and this breaks down to AFC plus AVC, right? Similar to what we had with our earlier identity in terms of total fixed and variable cost. That identity also holds for the averages, right? Average total cost is equal to the average fixed cost plus the average variable cost. That's a V, variable cost, right? Those are all useful pieces of information to have, but they're not the most critical piece of information. The most critical cost measure, and I'm putting, boy, what am I putting, like 18 stars by it, because this is so darn important, is the concept of marginal cost. And so again, one more time, when you see the word marginal, what's the word that should be jumping to your mind? Right, so the marginal cost is just equal to the change in the total cost divided by the change in Q. It's telling me how much additional cost I have from additional production. So it's telling me additional cost of additional units. That's what marginal cost is, and that's actually the most useful measure of cost that a firm should be using when they're thinking rationally about how much production they should do. So we can bring back some of this earlier story. Does this look familiar? Right? If you recall, this is the story that we told earlier in terms of production. We are about to draw a line between production and costs, and so I wanted to review that this was our story of production that we had. Now, I've got this. And notice, this is a little table of different costs. I've got my first column is quantity, right? So do those numbers look familiar? They should, 0, 6, 15, 30, 36, 39. That was the quantity that we looked at hypothetically from this nice little well-behaved production function, right? From our Subway hypothetical production function, we looked at different amounts of labor producing different amounts of Q, different amounts of output. Now, that's what we're starting with this chart, is we're starting given these different levels of output. And I want to break these different cost measures into 3 different sections. So my first section is going to be this first section that has the total cost, the fixed cost, and the variable cost. In a sense, these are my aggregate measures. These are the total cost, the total fixed cost, the total variable cost, right? They're looking at the full amount of something given a level of production. Next, I've got my 3 averages, and so this is the per unit stuff with the average total cost, the average fixed cost, the average variable cost, and then last, most important, is the marginal cost. So again, I've got a reminder of what the different formulas are. In a sense, do you all know what what these things are? You've probably seen these before, right? And I always think that these kinds of graphs are something like that, where you got to use different pieces of information to identify what it is. And so what I want to do is I want to spend just a little bit of time talking through the relationships that you see in some of these. And so we'll pause and then clean this up and start in. Okay, so first thing that you notice, right? We've got our Q is increasing. We're increasing the amount of subs that are being produced. Notice, how about this fixed cost column? Do you notice anything about it so far, right? It's got 30, 30, and then way down here it's got 30. In fact, do you know what these other missing values would be? They'd also be 30, right? Why? Because look back at what the definition of a fixed cost is. It's a cost that does not depend on the amount that's being produced. It doesn't depend on how many units are being produced. So, right, that entire column is going to be 30s. And in fact, right, also notice that the other thing that we said was a useful way to think about fixed costs. If you didn't produce anything at all, whatever costs you'd be incurring, those are your fixed costs, right? You put up the closed sign, and whatever it is, that's your fixed cost. And it's going to be constant down this entire row. But notice also that we have that the total costs are equal to the fixed cost plus the variable cost. We can go through and we can verify some of these numbers, and they all make sense. But now notice when we get down to this fourth line, I've got my total cost. I have my fixed cost, but I'm missing my variable cost. Can we do that with a little bit of algebra, right? Total cost equals variable cost plus fixed cost. And so if I know the total cost, if I take the total cost and subtract out my fixed cost, I'm left with my variable cost. Nice little identity, right? So this has got to be 24, right? And then also similar, yep, we've already done this calculation, so this should be 62. I don't know this though, right? I need two of the three pieces of information in order to use this little algebraic identity, right? I know what my fixed costs are. I don't know what my variable or my total costs are. Step back. Could you guess what the value would be for variable cost? Do you notice a pattern? The pattern in the variable cost, it looks like 0, 8, 16, 24, 32. You could probably make a good educated guess on what that value is, but you don't know for certain yet, right? Think about, again, what does the variable cost represent? The variable cost represents, if you want to produce more, what are you going to have to spend money on? And if we jump, I'm going to jump way, way, way back in the story, but if we jump way back in the story, if we're considering a short-run production function, what's the one thing that we can spend money on? It's labor, right? And so if we consider the changes to the variable cost, they're probably a reflection of how much we have to pay labor. It looks like there's a certain cost of adding additional labor, but it may not always be constant. Right? Depending on different labor market conditions, that number could get bigger or could get smaller. It looks like it may be constant, but it might not be. Let's hold off on that for a second. But I think we've done pretty much everything in the aggregate first three that we can do. So now we can move to the averages. Where do the averages come from? Notice again, the averages are undefined in that first line because we can't divide something by 0. But in the second line, right, we've got the total cost is 38 and the quantity is 6. Can we do that math? I want to make sure I don't mess this up. So 38 divided by 6, 6.33, right? So we go back, 38 divided by 6, that was the 6.33. But some of you who may have been paying close attention notice that that was totally unnecessary for me to bring that up because we had this other identity that the average total cost was equal to the average variable cost plus the average fixed cost, right? And so, yep, I know that the average fixed cost and the average variable cost, those were already given. So those two added together has got to be equal to the 6.33. And verifying the line below, 2 plus 1.7 is 3.07. But we can also verify where these numbers come from, right? We don't need a calculator for this, but 30 divided by 6, a fixed cost of 30 spread over 6 units, the per unit fixed cost is 5. My variable cost is only 8. I take this $8 of variable cost, divide it by my 6 units, and I get $1.33 of variable cost per unit produced. So here we go. You can look like a genius here, right? If we want to know what this value is, we need the value of total cost, or average total cost. So we take our total cost of 54, and we divide by a quantity of 30. Mathematically, can you do that value in your head real quick? Right, 1.80. Can we verify 54 divided by 30 equals 54 divided by 30? We can, but again, you could look like a genius because you could just take the 1 plus the 0.8, right? Notice when we get down to this, we can no longer use this little identity because we don't have those two pieces. So we actually need to carry out some of this calculation. Let's go ahead and calculate the average total cost first. So that's 62 divided by 36 equals 62 divided by 36, and I get 1.72. So I go 1. Oh, why is that coming up? 1.72. Now, mathematically, can you figure out what the average variable cost is without a calculator? It's a little bit complicated math, right? But if you take the 1.72 and you subtract this average fixed cost of 0.83, that should be 0.89 if I did my math correctly. Let's just verify that 32 divided by 36 equals 32 divided by 36. 0.89. Perfect, right? Again, I was just using this identity. I had two of the pieces of information to solve for the third. And again, we don't know these values because we don't know all of the values over here, but we can get them in a second after we turn to the last column, the average, not the average, but the marginal cost. So recall what the marginal cost does is it looks at the change in total cost divided by the change in quantity, right? So to carry this out, what value should go right here? Again, it's undefined for the first line because we don't have a previous line to compare it to, but we're calculating the change from one line to the next. So in my numerator, I've got the change in total cost. So I want to consider the change in the total cost to be 30 to up to 38. Mathematically, I calculate that change by 38 minus 30. And then in my denominator, I'm looking at the change in quantity. So I'm going from 0 up to 6. Now notice that this table isn't in 1 unit increments, and so this is a little bit more complicated mathematically, but the change going from 0 up to 6, I measure that as 6 minus 0. And so this is 8 divided by 6, or 1.33. Think about, well, what are the units? What are we measuring in the numerator? What are we measuring in the denominator? And what should the units be on the average, or on the marginal cost? Right, so we do the math, and what we have is we've got in our numerator, we've got 8, and that's the change in total cost, which was measured in dollars, right? And then in my denominator, I've got the change in quantity, which was, it depended on what we were measuring, right? It was units of production. If it's Subway, it's sub. If it's GM, it's automobiles. But this is, again, it's got the word marginal, so you should be thinking about the word additional, right? It's the additional cost of additional production. If I'm going to go from producing 0 to 6 units, it's going to cost me an additional $8. So my per unit cost of additional production, this is the cost of these additional units, was $1.33. Real quick, verify where 0.89 comes from, right? Again, mathematically, you should have in your numerator the change in total cost, 46 minus 38, and in your denominator, you're dividing by the change in the number of units produced, 6 up to 15, 15 minus 6. Again, just carry out that math and verify that the cost of those additional units was only 89 cents. And then the cost of the next set of additional units was 53 cents. And then what should this value be right here, right? Our change in total cost went up by 8, and our change in quantity was 6, so I can do that math in my head, 0.33. And now we get to the last piece, right? Here we are, I'm given my value of marginal cost. So what it's saying is that the change from 62 up to whatever number this is, we don't know what it is, so let's go ahead and call it X, divided by the change in the thing I'm measuring in my numerator, the change in the amount of output, is equal to 2.63. So here we go, right? How would I set up this calculation? What number X minus 62 divided by, in my denominator, 39 minus 36 equals 2.67. So again, real quick, pause and carry out that math. And if you did your algebra correctly, you should find, and this shouldn't be that surprising, 70 is the correct value of X. And again, not surprisingly, right, you might have had a guess that this was coming, right? Because up to this point, every time that we hired an additional worker and had output go up, that was our variable cost. And our variable cost kept going up by $8, right? So it's not surprising that the total cost went up by another $8. Variable cost, and now we can carry out the rest of these calculations, but it's not very interesting. We've already covered those, right? So again, we're assuming here that every single time that we expanded output, the cost went up by 8. The variable cost went up by 8. And every time we were expanding output, remember, we were hiring an additional worker. So built into this is the implicit assumption that every additional worker always cost $8. And what marginal cost was telling was that $8 of additional labor, how much additional output could we get? What was the per unit cost of that additional output? Marginal cost is the cost of additional output. And so we can real quick do one other thing. Remember, what did the graph of marginal productivity look like? If we graphed out marginal productivity, it went up, hit a maximum, and then started going down, right? Our marginal productivity of labor, we were looking at the amount of labor against the marginal productivity. It went up, hit a maximum, and then started coming down. Whereas if I just simplify my chart on the previous page, and I look at the quantity, I'm back to putting Q on the horizontal axis, right? If I look at the amount of production against the marginal cost of production, what shape does the marginal cost curve have? It is a U-shaped cost curve, and the minimum value corresponds, I don't have these lining up that well, but the minimum value, because I didn't highlight the minimum value. The minimum value there, that looks like that lines up a little bit better. The minimum value of the marginal cost curve lines up with the maximum of the marginal productivity curve, right? And in fact, there's an inverse relationship between productivity and costs, right? That when productivity is going up, specifically when marginal productivity is going up, our marginal productivity is going down. But again, that's not the interesting portion of the curve we said. The interesting portion of the marginal productivity curve is the downward sloping curve on the marginal productivity. And so what that means is that this upward sloping portion of the marginal cost curve, that's the interesting portion of the marginal cost curve. And again, think back to when we were talking earlier about that production possibility frontier, and we made this argument about having non-constant opportunity costs of production. For most things, we're going to experience higher cost, higher additional cost, the more we do of them, right? Think about studying for the next exam. That first hour that you study, what do you have to give up? The second hour that you have to study, the third hour, the fourth hour, the fifth hour, right? When you get to the 20th hour of studying, you're giving up something really valuable for that 20th hour of studying. Or said differently, your cost of production gets higher and higher and higher, right? So the other argument that gets made sometimes is this story of what we call the low-hanging fruit. And the story behind that, the quick argument that we can make is that consider an apple orchard where you've got a bunch of apples in a tree, right? If you want to collect your first bushel of apples, what do you have to do? Well, you have to go to the tree and you can very easily grab the lowest hanging fruit. It's not going to be very difficult. It will not take much time for you to fill up your first bushel of apples. But what if you want to collect a second bushel of apples? Now you've got to go back to this tree and you've got to stretch a little bit more to get the next highest round of fruit, right? You can get this second bushel, but it's going to be a little bit more difficult. It's going to take a little bit more effort. What if you wanted to collect a third bushel of apples? Now, when you go to this tree, you're going to need to bring with you a ladder, and it's going to be much, much, much more time intensive for you to collect these apples. What I'm arguing is that the cost of additional bushels of apples gets higher and higher and higher, right? And that's basically what an upward sloping marginal cost curve is saying. What does it come from? It comes fundamentally from this diminishing marginal productivity. There's this inverse relationship between marginal productivity and marginal cost. If we go back to this curve, right, we just talked about what the shape of this marginal cost curve looked like, and I described it as a U-shaped cost curve where it decreases, hits a minimum, and then starts increasing. Real quickly, can we talk through some of the shapes of these other cost curves as well, right? Think about the total cost curve. Total costs, as quantity increases, total costs get higher and higher and higher. That's not surprising. If you want to produce more stuff, you're going to have to spend more money. What's the relationship between quantity and fixed cost? It's a flat line, right? That by definition, those fixed costs, they stay constant regardless of how much is being produced. Variable cost also have to be an upward sloping line. Those aren't really that interesting. I want to talk a little bit about these averages, right? So first off, how about the average fixed cost? What was going on with the average fixed cost? It is a downward sloping line that gets smaller and smaller and smaller, and it asymptotically approaches the horizontal intercept, right? Because again, right, in your numerator of your average fixed cost, that's a constant number. Your fixed costs don't change, but your denominator, your Q, gets bigger and bigger and bigger, right? Here we go. Because we've got this diminishing, this increasing and then diminishing marginal productivity of labor, it has some implications for what the average total cost and the average variable cost curve looks like. Take a quick look at them and see what's going on, right? It looks like starts out like a high number, gets lower, 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 hits a minimum. We didn't do this calculation, but this calculation, 70 divided by 39, I guess I need to highlight this. 70 divided by 39 is 1.79. 1.79. It goes down, hits a minimum, and then starts increasing. It goes down, hits a minimum, and starts increasing. Hey, that's the exact same shape we were doing earlier with this marginal cost. Go down, hits a minimum, starts increasing. Guess what? The average variable cost also has this, right? So the average total cost, the average variable cost, and the marginal cost, we describe them in economics as a U-shaped cost curve. What I want to do next is I want to turn and I want to do a very, very general picture of what the different cost curves look like. So now we want to take a very, very general look at what cost curves look like. And so I'm going to do this as a very, very large picture. And I hope you follow along. Right? What are we measuring? So horizontally, vertically, what are we measuring? We are on the horizontal axis, we are still measuring quantity, right? So this is the quantity, but think for a second, what does this quantity represent, right? If this is Subway, we're thinking about this in terms of the quantity of subs produced. Is that a difference, different than the quantity that they sell, right? Implicitly, we're assuming that every unit that is produced is going to be turned around and sold in a market, right? But right now, when we have this quantity, we want to use the language of the units that are produced, right? But again, the thought is that it's going towards sales. We're measuring these costs. These costs we're measuring them in dollar terms, right? And so we're measuring the dollars, and we said that the number one most important cost curve is the marginal cost curve. And so if you recall, what does the marginal cost curve look like? The marginal cost curve is a U-shaped cost curve. So let's go ahead and draw a U-shaped cost curve. It's going to decrease, hit a minimum at some point, and then start increase. Maybe the minimum is right there, right? This is the marginal cost curve. And again, we can ask, why is the marginal cost curve have the shape that it does, right? The marginal cost curve has a U-shaped cost curve because of the shape of the production function, right? If you recall, there is this inverse relationship between production and costs. They are inversely related to each other. So when we've got a U-shaped marginal cost curve, it's because of having this specific shape in the marginal productivity of labor curve, which again comes from the underlying production process that generates output from labor. U-shaped marginal cost curve. Perfect. I also want to add my average total cost curve. If you recall, the average total cost curve is also a U-shaped cost curve, but follow along as I graph it out, right? So I'm going to draw it as a U-shaped cost curve, but I'm going to start up here, decrease, and I'm going to put its minimum right at the point where it crosses the marginal cost curve, right? I'm going to pause these and clean these up a bit. Okay, so this is the same general picture. These are just less shaky lines. I've got my marginal cost curve, which is a U-shaped cost curve. It hits its minimum at the point where the marginal productivity of labor is at its peak. The average total cost curve is also a U-shaped cost curve, but notice its minimum point is right at the point where it intersects with the marginal cost curve. So we can ask a little question. I'm going to add this to my chart. Follow along, but don't necessarily add it to yours. To the left of this point, right, what do you notice about the relationship between marginal cost and average total cost? Which way do I want to write my inequality? To the left of that intersection point, which of those curves is larger, the MC curve or the ATC curve? right? And so what we see is that to the left of this point, the ATC curve is greater than the MC curve. To the right of this point, what do we have? We've got that the MC curve is greater than the ATC curve. A great question that I want to ask is, can you explain in words what's the difference between the MC and the ATC? We can consider, right? So to the left of this point, marginal cost is less than the average total cost. If we're talking about something like auto production, right? So one of the big auto manufacturers, right? What's the ATC represent? That's the per unit cost of all of their auto production, whereas the marginal cost is the cost of one additional car, right? So what we have to the left here is that the cost of an additional car is less than the cost of, on average, what all the cars cost to produce. And to the right of that intersection point, the marginal cost is greater than the cost of the per unit. So we usually do this thought experiment. Think about the last time that you were in a classroom, right? And so if you're in a classroom and you've got 30 students or whatever in that classroom, you can think about what's the average weight in this classroom. If we calculated the average weight of a student in this classroom, think about what that would be, and then think about how we would calculate that, right? It's kind of like that episode of The Office, right? We'd all jump on a scale and we'd measure the total amount of pounds of the group and we divide it by the number of students in the class, and that would be the average weight. But then think about what if we had one more person join the class. If that one more person who joined the class had a weight of 300 pounds, what's more than likely going to happen to the average weight in the classroom, right? That average weight, if it's above, or if the additional weight of the 31st person is above what the average weight in the class was, it's going to pull that weight up, right? So think about, going back to our marginal and average total cost, think about, to the left of this point, what's the relationship between MC and ATC? The marginal cost, all of these additional units cost less than what the average is. Notice what's going on with the average. It's being pulled down. To the left, all of these additional lower cost units are pulling down the average. To the right of that intersection point, right, all of those additional units cost more than what the existing average was, right? That's kind of like the classroom weight example. What's happening to the right? The average total cost is being pulled up by these higher cost additional units that are being added, right? And so it must be, by that logic, that the point they intersect is when average total cost stops decreasing and starts increasing. That's got to be the minimum of the average total cost curve, right? In calculus, we'd refer to this as the mean value theorem, right? In general, we also can consider specific values of MC and ATC. So I'm gonna start this over and clean it up, and then have some specific values as an example. So what I did is I just put some hypothetical values, right? I've got a quantity of 20, and if I take that quantity up to my ATC curve, the value of ATC is 40, and if I take this quantity of 20 up to the marginal cost curve, the value is 70. So a good question is, in words, can you explain at a quantity of 20, what's the difference between an average total cost of 40 and a marginal cost of 70? All right, so again, we're talking about Q is measuring our amount of subs. ATC is telling us the per unit cost of all 20 subs. On average, each of those 20 subs are going to cost us, on average, $40. $40 per sub to produce those 20 subs. What does the marginal cost tell us, though? Remember, the marginal cost tells us the cost of an additional sub, right? So if we're producing the one additional sub at 20, so in essence, going from 20 to 21, right, that 21st sub is going to cost an additional $70. Right? So here we go. Can we calculate out a little bit of algebra and get some values? If we're producing 20 subs and the per unit cost is $40, can you calculate what's the value of total cost, right? Total cost is, right, so average total cost is equal to total cost divided by quantity, right? With a little bit of algebra, I can rearrange this thing and get that my total cost is equal to my quantity times my average total cost, right? So if I pull up a little bit of in Excel, we can say that if my Q and my ATC, if the value of my Q is 20 and the value of my ATC is 40, then the value of total cost is just quantity times ATC. In order to produce these 20 units, the total cost of producing those 20 units is $800. But notice we've also got something else. We've also got information about the marginal cost. The marginal cost is saying, hey, when we're producing 20 units, if we want to produce one additional unit, we know that total costs of 800 are going to go up by 70, right? So when we produce one additional unit, we're going to be producing 21 units, and the marginal cost tells us that our total costs are going to go up. When we produce this 21st unit, our total costs are going to go up by $70 to $870, right? That's what the marginal cost represents. The average total cost is telling us the per unit cost of all 20 units. The marginal cost is telling us the cost of one additional unit. But notice there's one more calculation we can carry out. If we know these two pieces of information, when we produce 21 units, if we know that the total cost is now going to be 870, can we calculate at a value of 21 what the value of ATC is? When Q equals 21, what's the value of ATC? It's the total cost divided by the quantity. If I go back to my Excel, I can do this, right? So we just calculated that when quantity equals 21, the total cost is going to go up to 870. It must be that the average total cost is the total cost divided by the quantity. Think about whether or not you're going to be surprised at seeing a number above 40, right? It's 41.4, right? This shouldn't be a big surprise because we have this U-shaped average total cost curve, and we're on the upward trajectory, upward slope of this thing, right? When we look at a value of Q equals 21, that value of Q, according to the average total cost curve, we just calculated it, right? It was 41.2, right? The average total cost curve tells us unit by unit by unit by unit what's the cost of all of those levels of production, whereas the marginal cost tells us unit by unit by unit what's the cost of each additional unit, right? Both are important pieces of information, but it's going to turn out that the marginal cost curve is the more useful curve for thinking about how a firm should produce for a market. So I pulled back and cleaned this up a little bit. Our number one most important cost curve is the marginal cost curve. Our number two most important cost curve is the average total cost, right? But again, think about what the difference is between those two cost curves. The other curve that we want to add to the story is the average variable cost. So again, this is another U-shaped cost curve. So I want to add on another U-shaped cost curve. I'm going to try to be a little bit careful with this, right? It's a U-shaped cost curve. It's going to be located below the average total cost curve, but it's got this very, very special shape to it, right? So U-shaped cost curve, it hits a minimum at the same point it crosses the marginal cost curve, but then it does this, right? And so if I'm trying to be really, really careful with this thing, right, what it does, it's a U-shaped cost curve, but notice that in the beginning point, the gap between the average variable cost and the average total cost curve, that gap is very, very large. But as we move to the right, that gap, if I was drawing this carefully, gets smaller and smaller and smaller. The AVC asymptotically is going to get closer and closer to this average total cost. So those are the properties of the average variable cost. Number one, it's a U-shaped cost curve. Number two, it also hits its minimum at the point where it crosses the marginal cost curve. But also number three, the gap between the AVC and the ATC gets smaller and smaller and smaller as we increase the quantity. Now think about why that would be, right? So we've got this identity that we had earlier. The average total cost curve is equal to the average variable cost plus the average fixed cost. The gap between the average total cost and the average variable cost, the difference between those curves, or mathematically, the average total cost curve minus the average variable cost is equal to the average fixed cost, right? The gap between these curves is the average fixed cost. And if you recall, what does the shape of the average fixed cost look like? It starts large and then it gets smaller and smaller and smaller. It asymptotically approaches zero. That gap starts out large, and then it asymptotically approaches zero. That gap, in essence, disappears, right? It never actually becomes zero, and these two curves never intersect, right? But they're going to get amazingly close to each other as the quantity gets larger and larger and larger. The average variable cost tells us what, right? So again, we can pull out a value. If the quantity is 20 and the average total cost is 40, it looks like, draw a mostly straight line, right? Let's say the average variable cost is 39. Can we hop back to Excel and do a couple of manipulations on that, right? So if it's the case that we're looking at that's column B, the average total cost is 40. If the average variable cost is 39, then what does it mean? It means that the average of the variable cost is the value of my average variable cost times the quantity, just like before, right? It means that out of the full total cost of $800, $780 of that is variable cost, which must mean how much of it is associated with fixed cost, right? So the fixed cost is the difference between the total cost and the variable cost, only $20 worth. And again, if I wanted to calculate my average fixed cost, that's just taking this fixed cost of $20 and averaging it over each of those quantities. Not surprisingly, it's a 1. I say not surprisingly because, again, AVC plus AFC, that's the identity that is giving me my AVC plus my AFC, not surprisingly, is equal to the value of my ATC. So again, that's the relationship. The number one most important cost curve is the marginal cost curve. The number 2 most important cost curve is the average total cost. The number 3 most important cost curve is the average variable cost. And when you know the average variable cost, implicitly, because of that identity, you know what the average fixed cost is. This is going to be important, right? So moving forward in the next few topics, we're going to look at different types of market structures. This generic form, this general form of the cost curves could apply to any of those market structures, right? And so this is going to be a useful thing for us to keep in our mind as we move forward with the next few topics. We have 2 other things that we want to briefly discuss before we move on from this discussion about costs. One is this concept of economies of scale, or diseconomies of scale, right? And so in order to think about this, we have to move from a short-run story to a long-run story. If you recall, the difference between the long run and the short run is that in the long run, all inputs are variable, right? Any of our factors of production can be changed. We can adjust any of our inputs, any of our factors of production. We want to define 2 things, right? So if I deleted LR from these stories for half a second, then, gosh, this looks identical to what we just talked about, right? We can define a cost function, a total cost, and the way that we find the average total cost is we just take our level of cost and spread it out over our level of production. This is our per unit cost of producing something. All that we're doing with adding the LR is let's add a long run story to it in the context of us being able to change any of our inputs, our land, our labor, our capital, being able to adjust any of those factors of production. What if we calculated the long run per unit cost of production? Okay, so this picture, right, it has to do with, formally, if you go on and study more economics, this has to do with the envelope theorem about minimizing the minimum point of the average total cost curve for our purposes. What do we need to do? We mostly need to focus on these points in blue. So notice, right, what are we measuring? We're measuring the amount of production. And we can think about this as the amount of production by an individual firm. And we've got vertically, what are we measuring? We're measuring the per unit cost of production. This is the long run average total cost curve. In blue, we can consider 2 different firms. Firm 1 that produces 10 units of output, and firm 2 that produces 20 units of output. Firm 2 is twice as large as firm 1. Notice in this downward sloping long run average total cost curve, what does that mean? That means for firm 1 that's only producing 10 units, their long run per unit cost of production is higher than for firm 2, which has a bigger operations, their long run average total cost of production, right? When we look at a per unit level of production, when we have economies of scale, larger scale of production results in a lower per unit cost. Let me say that again. When we have economies of scale, it means that for firms in our industry, the larger the scale of production, the lower the per unit cost. And so as a thought experiment, we can think about, right, what if we had a 30-acre farm? Or alternatively, in your mind, let's contrast it, and what if we had 1, 2, 3, 4, 5, I can't count that up. Let's just do a bunch of little boxes. What if instead we had 30 individual farms that were each 1 acre large? All right, so I couldn't help myself. I had to go ahead and actually create it, right? So we can think about if we've got 30 acres of land, there are 2 different ways that we could organize firms. We could have one farm do all 30 acres of production, or instead, we could have 30 individual farms that were each 1 acre large. Now again, think about this, right? How many acres of production are we going to get? We're going to get 30 acres of production over here on the left. How many acres of production are we going to get on the right? We're going to get 30 acres of production on the right. That's the same, the quantity is the same, but do you think the per unit cost, right? Think about the per bushel cost of producing corn. It's not going to be the same between these two, right? If we've got one single farm, think about the land, labor, and capital they're going to need versus if we had farms that were really small with just 1 acre large, right? They're going to need some land, labor, and capital, but think about how potentially inefficient it is to have farms that are this small, right? Each of these 30 farms would probably need some machinery. On the 30-acre farm, are we going to need bigger machinery? Sure we are, right? It's going to be more expensive, but is the machinery going to be 30 times the cost of the machinery for a single acre? Probably not, right? It's probably going to be a couple of times larger, but not 30 times larger, right? That's the scaling impact that we see with economies of scale, right? Economies of scale would say that the average per unit cost in a small farm is higher than the average per unit per bushel of corn cost of organizing our firm as a larger scale of production. That's what economies of scale are. And so again, as a question, we can think about, do you have any examples that jump to your mind where having a big scale of operations can do things at a lower per unit cost than having a bunch of smaller firms do the same scale of production? You can think about what are the implications, right? From an economic perspective, what do I want to see? High cost of production or low cost of, did that backwards. High cost of production or low cost of production? From an economic perspective, right? I like seeing my costs low. So it seems like we'd be happy to have large scale production, right? It seems like when there are industries where we have economies of scale, there might be some real benefits in terms of lower costs of having big firms dominate those markets. You might want to think for a second about, are there any downsides to having large scale of production? That's what we have with when industries experience economies of scale. Not all industries do, right? Different industries can be located at different points on this long run average total cost curve. Those that are in the middle in red, what do we see? It doesn't matter the scale of the production, the per unit cost always remains the same, right? Doesn't matter whether you have one unit or whether you're producing 10,000 units, the per unit cost is always going to be the same. How about for the other one? If we have diseconomies of scale, it's actually the opposite, right? You could think about firms, if they get too big, there might be some shirking that goes on when our workers aren't quite working as hard as they otherwise would. It can actually drive up the per unit cost of production. That scenario is called diseconomies of scale, but again, for the most part, our emphasis is going to be on economies of scale. Very quickly, we want to talk about 2 other possible cost concepts. So economies of scale are the big one, where it's about the scale of operations. Another related but different concept is economies of scope. What economies of scope are is when the production of two products together is a lower cost than if we were to do those two products produced separately, right? And so one of the classic examples is when you think about donut holes and donuts, right? Think about how ridiculous it would be to have two different companies. One company that only produced donuts, and right next door, another company that only produced donut holes, right? My goodness, each of those stores would have to pay a manager. Each of those stores would have to pay an accountant to keep their books, right? There's all of these extra costs that would be redundant between the two. Hey, instead of organizing it as two separate firms, what if we had just a single firm that produced both donuts and donut holes, right? Or you can think about restaurants. Same thing. If you've got a restaurant that only produced chicken meals and another restaurant that only produced beef meals, right? I have no idea. But we can think about how, yeah, they both need ovens. So maybe it's possible, right, that you could combine those operations into a single firm and use the ovens for both productions, and that could be a way to try to save on some costs. Economies of scope are not about the scale or the size of products, but rather they're about a diversity of products, right? It's about the scope or the diversity of products being a way to capitalize on some cost advantages. Lastly, when the last thing we want to talk about is an experience curve, right? So the costs in an industry can be related to your experience, right? So notice, what are we measuring horizontally? It's not the quantity that's being produced today or the quantity that's produced in this given time period, but this is the cumulative quantity that's produced. So over the long history, right? And so a lot of industries are going to experience this kind of downward sloping experience curve, where what is it saying? It's saying that the longer firms have been around, the lower their costs of production are, right? And we're thinking about this primarily as like a per unit cost of production. You could think about, yeah, right, intuitively, this makes a lot of sense. Think about the very, very first year that a business opens. You think about a small mom and pop shop, one of these small entrepreneurial things. In their first year, gosh, how much do they waste their efforts, right? They're probably doing a whole lot of stuff that's really inefficient because they just don't know the ins and outs of how to make their production a little bit more clean and efficient. But gosh, after they've been around for 10 years, they know what's important, they know what's not important, and they've figured out a way to do lower cost production after their 10th year of production. That's all that a downward sloping experience curve is, right? But you could think about, again, if we have industries with downward sloping experience curves, then it means that if we've got some firms who have been around in the industry for a long time, how easy is it going to be for a newcomer to jump into that market and effectively compete against those firms who have already capitalized on gaining all that experience? That might be a little bit more of a difficulty. And so, in a sense, this experience curve can also, from an economic perspective, help to give these people who have been around for a while more of a leg up, a little bit more of an advantage in the market, right? The other thing I want to point out is we've got this downward sloping experience curve, but can you think about different industries might have different shaped experience curves? If you have an experience curve that's completely flat, what does that mean? Right? Whereas if you have an experience curve that is very, very steep, what does that mean? Right? There's the shape of this experience curve conveys something about how much learning in a market and experience is able to reduce costs.